Chapter 11, Example 3, Damage Stability Calculation. Here we have a semi-submersible that has damage to the port forward corner column, ballast tank number 33. We have to calculate the drafts on the four corners. So the displacement of the rig is 51,496 tons with a vertical center of gravity of 23.36 meters. So the vertical moment, when you multiply these together, is 1,202,946.56 ton meters. Now, because of the damage to tank number 33, we have an increase in weight of 363.84 tons. The vertical center of gravity, 21.658 meters. You multiply these together, you get a positive vertical moment of 7,880.05 ton meters. Now for this calculation, you're also going to need the transverse center of gravity for this particular tank, which is 34.069, and that's to port. And your longitudinal center of gravity is 23.794, and that is forward. So if you sum up your weight column, you end up with 51,859.84 tons. If you sum up your vertical moment column, you get 1,210,826.61 ton meters. So now we can calculate our vertical center of gravity. And our vertical center of gravity, the formula is your vertical moment divided by your total weight. We calculated our vertical moment to be 1,210,826.61 ton meters. And the total weight was 51,859.84 tons. So when we divide our weight into our vertical moment, we get our vertical center of gravity of 23.35 meters. So next we need to calculate our transverse moment. The formula for our transverse moment is the weight times the transverse center of gravity for tank number 33. The weight is 363.84 tons. And your transverse center of gravity is 34.069. So when you multiply these together, you get a transverse moment of 12,395.66 ton meters. So now we need to calculate our longitudinal moment. And our formula for the longitudinal moment is the weight times the longitudinal center of gravity for tank number 33. So the weight is 363.84 tons. And the longitudinal center of gravity is 23.794. So when you multiply these together, you get a longitudinal moment of 8,657.21 ton-meters. So now that we've calculated our new displacement of 51,859.84 tons, we need to determine what the draft is. When we look in our hydrostatic tables for this displacement, we find that it falls between a draft of 8.8 meters and 8.9 meters. So a displacement for a draft of 8.8 meters is 51,857.06 tons, and the displacement for 8.9 meters was 51,977.60 tons. So to interpolate, you take the difference between these two displacements. So that's 51,977.60 minus 51,857.06. You get a difference of 120.54 tons. So now you take the new displacement, which was 51,859.84, and you subtract the displacement for a draft of 18.8 meters, 51,857.06. You get a difference of 2.78 tons. So if you take 2.78, you divide it by 120.54, and you multiply it by 100, you get a percentage of 2.3%. Now from the hydrostatic tables, we need to obtain our KML and our KMT. So for a draft of 18.8 meters, your KML, which is your longitudinal KM, is 29.59 meters. And your KMT, which is your transverse KM, is 28.96 meters. And for a draft of 18.9 meters, your longitudinal KM is 29.57 meters. And your transverse KM is 28.93 meters. Now in this case, since there's such a small margin between your KML and KMT for these two drafts, calculating a difference of 2.3% by interpolation would result in such an insignificant difference it would not be noticeable when rounding out to 2 decimal points. Therefore, use the KML and KMT for the draft of 18.8 meters, which is the closest draft to the new displacement of 51,859.84 tons. So now we can calculate the moment to change your trim 1 centimeter and the moment to change your heel 1 centimeter. So your formula for your MCT is your displacement times your longitudinal km minus your corrected kg divided by 100 times the length. And the length is the distance between the forward and aft draft marks. So the displacement is 51,859.84 tons. Your longitudinal km is 29.59 meters minus your corrected kg, which is 23.35 meters, divided by 100 times the length of 61.5 meters. So your moment to change your trim 1 centimeter is 52.62 ton meters. So now we can calculate the moment to change our heel 1 centimeter. And the formula for this is your displacement times your transverse km minus your corrected kg. And this is all divided by 100 times the length. And the length is the distance between your port and starboard outboard draft marks. So our displacement is 51,859.84 tons times your transverse km, which is 28.96 meters, minus your corrected kg, which is 23.35 meters, divided by 100 times the length, which is 78 meters. So your moment to change your heel 1 centimeter is 37.29 ton meters. Now next, we'll calculate the trimming moment and heeling moment. So the formula for your trimming moment is the trimming arm times the weight. Your trimming arm is the distance between your longitudinal center of buoyancy and the longitudinal center of gravity. And since the LCB is 0, the trimming arm is equal to the LCG from the table. So your trimming arm is 23.794 meters, that's forward, times the weight, 363.84 tons. So you have a trimming moment of 8,657.21 ton meters. For our heeling moment, the formula is our heeling moment equals the heeling arm times the weight, and the heeling arm equals the distance between your transverse center of buoyancy and the transverse center of gravity. And since the TCB is 0, the heeling arm is equal to the TCG from the table. So So therefore your heeling arm is 34.069 meters to port times the weight, 363.84 tons. This will give us a heeling moment of 12,395.66 ton meters. Next, we're going to calculate the trim and heel. So the formula for your trim is the trimming moment divided by your moment to change your trim 1 centimeter. Your trimming moment is 8,657.21 ton meters divided by your moment to change your trim 1 centimeter, which is 52.62 tons. So your trim will be 1.645 meters. Now to calculate your heel, the formula for heel is your heeling moment divided by the moment to change your heel 1 centimeter and your heeling moment is 12,395.66 ton meters. And the moment to change your heel 1 centimeter is 37.29 tons. So your heel is 3.323 meters. Next, we're going to calculate the new mean drafts for the forward and the aft ends. So our mean draft forward, that's going to equal our mean draft plus half the trim. The mean draft is 18.8 meters. Plus half your trim, so that's 0.5 times your trim, which is 1.645. So your mean draft forward is 19.6225 meters. Now we'll calculate our mean draft aft. The formula is your mean draft minus half of the trim. Our mean draft is 18.8 meters minus 0.5 times the trim, which is 1.645. So our mean draft aft is 17.9775 meters. So now we have all the information we need in order to calculate the draft at the four corners. So for our mean draft forward, we calculate it to be 19.6225 meters. For our mean draft aft, We calculate it to be 17.9775 meters. So now we can calculate our drafts on the four corners. So port forward, we take our mean draft forward, and we're going to add half of our heel. So we get a draft port forward of 21.284 meters. For starboard forward, we're going to take our mean draft forward and subtract half the heel. So we're going to get a draft starboard forward of 17.961 meters. And for port aft, we're going to take our mean draft aft and add half of our heel. So our draft port aft will be 19.639 meters. And for starboard aft, we're going to take our mean draft aft and subtract half of our heel. So we're going to get a starboard draft aft of 16.316 meters.